Polonium-210. Polonium-210 is a radioactive isotope of polonium. Polonium is located on the metalloid section on the periodic table of elements. It has an atomic number of 84, which signifies that it is radioactive. Polonium-210 was discovered and primarily experimented on by Marie Curie and her husband Pierre Curie. She named it after Poland. As well, their daughter died due to tuberculosis, which had originated from exposure to polonium. The polonium-210 was found in pitchblende, a product of uranium. So what exactly does 210PO really mean? Well, PO is the element symbol for polonium, and 210 is the number of nucleons. But what are nucleons? Well, nucleons are the particles which make up the nucleus, in this case neutrons and protons. Polonium-210 has 84 protons, and by doing simple math we can find out that polonium-210 has 126 neutrons. Polonium-210 undergoes alpha decay. Polonium-210, being the parent nuclei, emits an alpha or helium particle, and it transmutates a daughter nuclei, in this case lead-206. Polonium-210 has a half-life of 138 days. This means every 138 days, half of the original mass will remain. On the left is a chart which shows the exponential decrease of polonium-210. Polonium-210 comes from the chain decay, which starts from uranium-238. This is the natural decay process which eventually gives us polonium-210, which is at the bottom of the stepladder. Polonium-210 can also be made artificially by bombarding bismuth-209 with neutrons. This gives us bismuth-210. Bismuth-210 naturally decays to polonium-210. This bombardment can only be done in a nuclear reactor, just as it speeds up the process. Polonium-210 has a wide range of uses, from thermoelectric cells on lunar rovers to static brushes and poisoning to weapons. Its first use as a static brush. Static eliminators or static brushes are filters that are used to eliminate static in industrial settings, such as in photography and in laboratories. The concentration of polonium-210 is very minute and is highly regulated. It is important to remove static in photography because on the negatives, it gives you a clearer image without the static. In laboratories, static is removed to ensure that the results and research are not compromised. Poison. Polonium-210 is a deadly poison that has been used by governments around the world to kill people. The most popular and recorded example of death by polonium-210 is of Alexander Litvinenko, who was killed by the Russian FSB for defecting to the United Kingdom. It is very dangerous as second-hand poisoning can also occur. On the left, the diagram shows how Litvinenko died. Polonium-210 is harmless to touch, but once ingested, is fatal. The polonium-210 found its way into his liver, which eventually led to liver decay, and he died. The isotope has far too many negative effects on the world to outweigh its limited positive effects. It can be used to create highly dangerous weapons. As well, it is very expensive to manufacture in nuclear reactors or mine from the earth. It is very toxic to those handling it. As well, use and extraction of polonium is propagated by politics. Despite having many cons, polonium-210 does have feasible application in the commercial settings. There are strict government regulations on the isotope, and it can be traced using alpha-ray spectroscopy. And if it is used as a poison, it can be traced. These all lead to polonium-210 being used safely in industrial settings. Thank you for watching. The citations are in the description below.